Okay, so we're going to repeat step 6 because before we use this condition, there's also another condition I should apply. And the result that actually we got from step 5, actually this boundary condition here, this one here is not quite right. So that's why I like to recap this one. So this is not correct. Please correct it. So we're not going to do this, and we're not going to do step 6. So we're going to continue with a new step 6. Okay. So first, from step 5, we apply the boundary condition at y1 when x1 is 0. And that means what? That means this. For the bin column, which is something like that. The first boundary condition we apply was at here. When x1 is 0, y1 should be 0, which is this point right here, right? And also, at this point, there's also another boundary condition. This is the boundary condition when we say that if you let the x1 to be L, which is the total length, you also will not have any deflection. That means when x1 is L, y1 also will be 0. Correct? So from the first one, which we use this boundary condition, we found A to be 0. Next, we're going to use this boundary condition to find the next parameter. When we do, we say that y1 when x to be L must be 0. That's the other support. And of course, to do this, this is actually not going to be, this is going to be by plugging D2. So here we're going to have C, which is capital C. Capital C times cosine KL. Now you will notice that I'm going to write cosine of KL like this. I'm going to skip the parentheses because there are lots of parentheses. Unless it's going to be cosine K times L, then I'm going to specify that. Otherwise, I'm going to write cosine of KL like this, just to skip lots of parentheses that I'm about to write. So this means C, capital C times cosine KL plus capital D times sine KL minus 0 must be 0. And from here, we know that the relationship between capital C and D is just capital C equals to negative capital D times tangent KL, right? Because we simply divide everything by cosine KL, and sine over cosine is tangent. So we have this relationship. This is what we found for now. And we're going to come back to continue with step 6. Now we know that when y1 at L minus C equals to y2, when x2 equals C. That is the boundary condition we want to use, which is nothing but to say that when y1 and y2 joined, which is somewhere here, correct? Deflection must be the same. No matter you calculate from the left-hand side or the right-hand side, they must be the same. Then what we do is just to plug in the expression of y1 and y2 to relate these two. And that's where we're going to get this expression, which is, because this is true, therefore, B times sine K times L, capital L minus C, minus Q times C over PL times L minus C. This must be equal to capital C times cosine K times regular C plus capital D times sine K times C minus Q times C over PL times L minus C. Now, of course, this will cancel out. So what we have is this expression, and therefore we can just rearrange this to have B times sine K times L minus C equals, because capital C can be replaced with capital D from what? From this one right here, we just found. Therefore, I'm going to write this way, capital D times this whole thing, which is sine Kc minus tangent Kl times cosine Kc. And we call this equation 7. And let's continue. So next one is...
Sorry, can you go back for just a quick second?
Yeah, please, for 1 second.
Is the last element Kc, cosine Kc?
Mm-hmm. You can plug in here simply by replacing this C here with this. Then you can get this expression.
Professor? Are you using a lowercase c or are they all capitals?
Which one? The Kc, the C with associated with K in cosine and sine is that's regular. But the coefficient capital C equals to, in this case, negative D times tangent KL. So there are two C's here. One is the regular and the other is capital. The capital C is a coefficient. Regular C is a constant. So there are two C's here. Just be careful. By replacing capital C with this negative D times tangent KL, we get rid of capital C in the expression 7. That's what I'm trying to do. Right?
Yep, thank you.
Yep. And so next one is what? Step 7. Then step 7. We're going to use the slope condition. So what's the slope? In addition to have the deflection with the spin column, we also have this. We also know that somewhere when they joined, for x1 and x2, somewhere here, the slope at this point must be the same, because the slope here is something like that, right? Not only the deflection should be the same, the slope should also be the same. Now, how do we know the slope condition? The slope condition can be obtained by letting this y1 prime when x equals to L minus C equals to y2 prime when x2, this is x1, equal to C. What does prime means? Prime means the space derivative. So y prime equals dy dx. And what if y double prime? What is y double prime? Double prime means second order derivative. That means d squared y over dx squared, and so on and so forth. So for this part, actually, this is the first homework assignment. I'm not going to tell you this, but you can actually get expression of y1 prime and y2 prime by differentiating the expressions of y1 and y2 with respect to x1 and x2. Then you can relate these two together. But I'm going to give you the result. If you let this to be true, then the y1 prime, when x equals to L minus C, will simply become this. Become B times K times cosine K times capital L minus C minus Q times C. It's actually Q times L minus C. L minus C over PL. This should equal to y2 prime when x equals C, which is negative capital C times K. Why does it K? Because you differentiate sine and cosine with a K in it. So when you differentiate it, we'll take K out. That's why you see K's everywhere here. Times sine K times C plus capital D times K times cosine KC and plus capital Q times C over capital P and capital L. Now, by relating these two, this is going to be our equation 8. This is equation 8. Of course, what we're going to do is to replace this capital C here with what? We're going to replace capital C with capital C equals negative D times tangent KL. This way, capital C will be gone. Just like what we did with equation 8. With equation 7. So in equation 8, there will not be capital C because capital C will be replaced by capital D. And in this case, the constant terms will not be canceled out because they're different. So this is this is the first problem in your homework number 1, is to practice and substitute all these terms to prove that you can get the final result. And why we can find out these two is because in equation 7, we have 2 unknowns. One is B and D, right? And in equation 8, you also have 2 unknowns, which is also B and D. Of course, this one eventually is going to be D. That means we have 2 conditions and 2 unknowns. Of course, we can find B and D, correct? That's what we learned in the past. So that's your homework number 1. And in the end, capital B equals this, which is capital Q times sine KC over capital P times K over sine KL. And capital D is going to be this. It's negative capital Q times sine K times L minus C over P over K over tangent KL. And capital D is just capital Q times sine K times L minus C over PK.